Welcome to lecture 3 on how to measure climate. This lecture has 3 parts, and in the first part we focus on annual mean surface temperatures. So global mean surface temperatures, because they just play such an important role in the discussions about global warming. So how do you derive global mean temperatures? How do you measure globally? Okay, that's the first part. And at the end of this first part, we look at some selected globally average temperatures to decide whether there's global warming or cooling. Okay, where there has been some discussion on that in the past. In part B, we focus on regional climates, on measurements of temperature and precipitation from weather stations, and I want to show you a method how you characterize the climate of a region using so-called climographs. Okay, I can show you several examples of climographs. In part C, we focus a little bit more about on the soil conditions in an area. Because we look at the water budget. Okay, so how long does that region stays humid as opposed to dry conditions? It will be a little bit more than only precipitation. We also look at evaporation. So I introduce you to the bucket methodology and show you some examples. But I also introduce you to drought indices like the Palmer Drought Severity Index, which is a very popular index used in the climate sciences. Okay, let's get started. Let's look at annual mean surface temperatures. First, the question is, how do you derive it? Seems to be a tricky task. So first thing that you can do is you can look at land-based measurements of temperatures from weather stations. But hang on, yes, you know that the land only occupies 30% of the surface of Earth. Well, that's a little bit of a problem, isn't it? Because you don't have everything. You expect that you get a land bias. Anyway, let's start with surface-based weather measurements, ground-based weather stations. Okay, we have a very, very long time series. The longest time series of meteorological data, mainly temperature, is from central England. And it's shown here above my head. And it extends longer than 350 years. It's a long time series. And you can see different phases of the climate and almost starting in the so-called mini ice age. Okay? At that time before the 700s and so, but going into the modern times. All right, it would be nice if we had such long time series everywhere on Earth, but it's not the case. So instead, we show you a map. The map that's shown here shows you the weather stations as dots and also indicators for how long they have been running. Okay, so you can see here is the color code tells you how long a weather station is running, with red corresponding to 100 years, the black ones even longer than 150 years, and so yellow-green corresponds to 50 years, and the blue ones, less than 20 years. Again, you can see that there is a sparse resolution in some areas, very high resolution in other areas, and indeed, that sometimes you have in cities, you have the problems of the urban heat island, so you get some effect because of the vegetation of land, of city areas, and so on. That all needs to be corrected. So it's not an easy business to do all these corrections. Okay, but that's what you have. Okay, direct measurements of temperatures. Okay, you indeed also have measurements from islands, which are also shown here. These are mainly island-based measurements and some sea-based station too. Okay. So, all right. So the other way to measure temperatures is using satellites. Okay, satellite data. Okay, satellites either move around the Earth or they stay at the same location, geostationary satellites, but they can determine the surface temperature through the principle of thermal radiation. Okay, so satellites are available since the mid-1970s, which gives you something like 50 years of data based on the detection of thermal radiation, and you know what thermal radiation is. Okay, sea surface temperatures and cloud top temperatures can be determined fairly accurately. Okay, land surface temperatures are more difficult to extract. Okay, so essentially what you get is sea surface temperatures, and that gives the other bit of the global average information, okay, that you don't get from ground-based measurements. Okay? Just as a note, you can also get from the infrared emissions from CO2, you get stratospheric measurements of temperatures as well. And you can compare different methods. You can look at direct surface measurements versus satellite measurements and put it in one graph, and you can see that there's a high correspondence of these these observations, okay, of surface measurements. Okay, and you can also noting that this one shows temperature anomalies with reference to some initial value, some reference value, some constant. Okay, and all that matters here is to see these variations and to see the trend is the gradual change. Okay, the gradual change that you see here. Okay, I'll show you one example now, and that was quite some drama. Okay, quite some drama. Okay, and it's based on the data that's shown above my head. Okay, let's go there. These are global land-ocean temperatures, okay, temperature anomalies based relative to some constants from 1880, and showing you annual mean are these dots, and a 5-year running mean. So what is a 5-year running mean? It's you use 5 years of data, you work out the mean value and plot it in the center. So you have 5 values, determine the average, put it into the center, and then you move this averaging window 1 year ahead and do the same thing. 5-year running mean. You're having average window which runs across the time series, and you get a smoothed curve. It's this red curve. You see, it's a little bit smoother. It doesn't have these big year-to-year variability in it. So why was this a drama? It was a drama because there was just a big IPCC report to be released, and what happened here? From 2000 to 2010, there was not much temperature change. And there were climate skeptics coming and saying, oh, there is no global warming. And actually, there's even a little bit of global cooling here during these 10 years. And that was a big moment in some. You can trace back what actually happened during that time. Even in Australian politics, what happens during this time had some political consequences during this time. I just mentioned that much. Okay. And this one was called the global warming slowdown, or the hiatus of that. And the question was, is the global warming or cooling? And the key answer is that you cannot determine global warming from time series which are too short. So if you only look at 10 years of data, no, you don't get an answer. Okay, and this is something that has been published here by Easterling and Wiener in Geophysical Research Letters, and they look at observations and just grab time series. This is from 1977 to 1985, and if you look at that window here, actually not that much on average warming during this time, or from 1981 to 1989, not much warming. If you look, also you look at climate predictions into the future, 2016 to 2031. In climate predictions, there are times where you have little warming on that short time scale. In any case, this was also a big rattle for the climate science community of, the climate scientists, because they could not understand this either. Okay, we now know what caused this event. This one was a transient event, and I will discuss it in future lectures because that's really interesting to see what happened here. Okay, so this one, watch out for a discussion of this feature. All right, so this one is the end of the first part of this lecture.